In this video, we are going to be solving problems on binomial expansion. Now let's look at this example. Find the constant term of the expansion a plus 3 raised to the power of 7. Now what is the constant term of an expansion? The constant term of an expansion is the term that is independent of the given variable. So for instance, if I have the result of an expansion which gives us x squared plus 2x plus 7. Now the constant term of this expansion is 7. In other words, we can say that the power of the variable of that expansion is 0, where I can rewrite 7 to give me 7 raised to the power of 0, and anything raised to the power of 0 is 1. So that will still give us 7. Now, the general formula for binomial expansion is given as, if I have a plus b raised to the power of n, we are going to have the summation of from 0 to n of n combination r, a raised to the power of n minus r times b raised to the power of r. Now this will give us the sum of the terms of that expansion. But if we are looking for a specific term of that expansion, we are going to be using n combination r, a raised to the power of n minus r, b raised to the power of r without the summation. Let's go back to the question. A plus 3 raised to the power of 7. A is the same thing as a here, b is 3, and n is 7. So the constant term will give us when we have n, or is 7 combination r, a raised to the power of n 7 minus r, and 3 raised to the power of r. Remember, we said that the constant term is when a is raised to the power of 0. So we are going to take a here and equate it to a raised to the power of 0. So that will give us a raised to the power of 7 minus r equals to a raised to the power of 0. And we find the value of r by comparing the powers to have 7 minus r equals to 0. R is 7. So at r is equals to 7 is when we will have the constant term. So let's plug 7 back into this term, and we are going to have 7 combination 7, a raised to the power of 7 minus 7. Of course, we are expecting the power to be 0. 3 raised to the power of 7. That's equals to 7. This was 7, sorry. 7 combination 7 is 1. But if you don't know how to do that, you can always use your calculator. So this is 1, this is 1, and we have 3 raised to the power of 7. And the term that is independent of x, or the constant term of that expansion, is 3 raised to the power of 7. Let's look at another example. Find the constant term of this expansion. So we have that a is equals to 2x, b is equals to 1 over x, and n is equals to 8. So we are going to have that 8 combination r, 2x raised to the power of 8 minus r, and 1 over x raised to the power of r. So we simplify this to have 8 combination r times 2 using loss of indices, 8 minus r times x raised to the power of 8 minus r times 1 over x is the same thing as x raised to the power of minus 1 now times r. So this will give us 8 combination r, 2 raised to the power of 8 minus r times x raised to the power of 8 minus r times x raised to the power of minus r. We use law of indices to combine the x, so that will give us 8 raised to the power 8 combination r times 2 raised to the power of 8 minus r times x raised to the power of, so we'll have x raised to the power of 8 minus r plus minus r. Minus r minus r will give us 8 raised to the power of minus 2, 8 minus 2r. So the constant term is when we have x to be raised to the power of 0. So we are going to be taking x raised to the power of 8 minus 2r and equate it to x raised to the power of 0. Comparing the powers to find the value of r, we'll have 8 minus 2r equals to 0. 2r will be equals to 8 and r is 4. So we'll come back to this term, plug the value of r, which is 4, to have 8 combination 4 times 2 raised to the power of 8 minus 4 times x raised to the power of 8 minus 2 times 4. And of course, we are expecting the power here to give us 0. So when we simplify that, we're going to have 8 combination 4 times 2 raised to the power of 4 times 8 x raised to the power of 2 times 4 is 8. That will give us 0. Now, if you don't know how to find 8 combination 4, you can always use your calculator to do that. So if we find 8 combination 4, that will give us 70. So we'll have here 70 times 2 raised to the power of 4 will give us 16 times 1, and that will give us 1120 as the answer. Let's take one more example. Find the term independent of x in the expansion. So a is equals to x squared. We have b is equals to 2 over x, and we have n equals to 9. So the constant term, or the term that is independent of x, will give us 9 combination r x squared raised to the power of 9 minus r times 2 over x raised to the power of r. So we are going to have 9, simplify this, combination r x raised to the power of 2 times 9 minus r. Then this will give us 2 x raised to the power of minus 1 raised to the power of r. This we use law of indices. I believe you can do that. 9 combination r, simplify this to have x raised to the power of 18 minus 2r times 2 raised to the power of r times x raised to the power of minus r. So we simplify the x together using law of indices, and that's going to give us 9 combination r times x raised to the power of 18 minus 2r minus r will give us minus 3r times 2 raised to the power of r. So the constant term is when a x raised to the power of 18 minus 3r is equals to x raised to the power of 0. So we equate 18 minus 3r equals to 0. We have that 3r equals to 0, 18, sorry. R is now equals to 6. So we are going to plug in the value of r in this term to have 9 combination 6 times x raised to the power of 18 minus 3 times 6 times 2 raised to the power of 6. So that will give us 9 combination 6 times x raised to the power of 0 times 2 raised to the power of 6. So let's come back to our calculator, and this will give us 9 combination 6 is 84. So we are going to have 84 times 1 times 2 raised to the power of 6 will give us 64. So at the end of the day, we have 84 times 64. So if we go back to our calculator, we'll have 84 now times 64. So that will give us 5,376. And that's our answer. I hope you understood that. Please, if you're new to this channel, consider subscribing, and I'll see you in my next video. Thank you.